All right, now it's recording now. Good afternoon, everybody. I got emails saying that you're having trouble with the homework and all this other stuff. So I thought I might help out with a couple of these, just so we're on the same page. The first kind of problems are really just straight up quadratic polynomials that you're just going to factor. Sometimes you're going to do more than just do quadratics. You might do common factors, difference of squares. It definitely matters. So the first one I'll do is let's see. Let's do, I think there's 13, 14. Where's the rest of them? Oh, well, no, not 15. Let's say 11. All right, if I do number, oh, you guys can't see that. Hold on. Now you can see it. All right, let's talk about number 11. Looking at this, uh, basically the rules are to factor. Now, you are going to cause yourself to do a lot of work if ultimately from the first part you're going to go from here. It's basically a lot. Like, it might be ideal to find out if in fact it has common factors first. So I'll ask you, is there common factors between 21, 58, and 21? Actually, there aren't. I don't think there are. So, since you don't think, since there are no common factors, I guess we do gotta go that way. Oh man. All right. So let's factor the 21y squared. I'll start with y and 21y. That works. Some more that work. Nope, 2y doesn't work. 2y does not work. How about 3y times 7y? That works. I think that's it. I think those are the only ones that we can actually use on this case. Over here, that means over here we can use y times 21y. And we can use 3y times 7y. So we have to find some kind of combination where some way, somehow, it's going to give us that. So let's push forward, see what we can do. Over here, ideally I want to try 3y and 7y over here. So let's try that one first. And then over here, notice that this is a plus and this is a plus, so we don't have to really worry about the signs. Wait a minute, let me expand on this so I have some room to work. Let's put my 3y and my 7y. And I already know that this is going to be plus and this is going to be plus. Why? Because of my signs. So then from here, let's really try to find out if in fact I can combine to get 58 some way, somehow. And I think I already see it. What if 7y went here and 3y went here? Let's find out. This right here is going to give me 49y squared, right? Or 49. Oh, you know what? You know where I messed up? Sorry about that. Let's start over. Where I messed up is that this isn't y right here. This is actually x times 21x and 3x times 7x. So when I come with my parentheses, I want to put a 3x here. Why does that keep disappearing? And I want to put 7x here. And then from here, I want to put 7y here and 3y here. Plus signs, plus signs. Does that work out? We'll find out. It's going to be 49xy. And this right here is going to be 9xy. Now you tell me, if you combine those, is that going to give you 58xy? I believe so. So what that means is we got it. Alright, that one's fairly easy, right? So let's zoom out again. Let's keep on scrolling through. I did that one. Now the ones on the second page, For the most part, those are factoring by grouping problems. Anytime you see a polynomial that has 4 terms, chances are you're going to be grouping. So let's do 16. We can do 16. 16 should be fairly easy. Let me put this right here in the middle so that, well, kind of in the middle. And so we can work. All right, so from here, you can't really do anything else. You can't do common factors. You can't do common factors. You can't do dots. And you can't do quadratics. So what you could do is grouping. You can do those later, but what you can do now is grouping. So what I'll do is in parentheses, I'll take this, and I'll take this, and in between goes a plus sign. So if I do that, let's rewrite. On one side I have x cubed minus 5x squared, and on the other side I have 3x minus 15. Now you ask yourself, what do they have in common? What does this binomial, what do those two terms have in common? What they have in common is x squared, right? So what you do is you can take out an x squared, and what's left inside? Left inside, I would say x minus 5. Over here, what these two terms have in common is 3, right? Oh, let me get my plus sign there. And if I take a 3 out, what I have left inside is x minus 5, right? So now if I drew parentheses around this entire thing, here, here, what do these two terms have in common? They have x minus 5 in common, don't they? So I'll take an x minus 5 out, and what's left inside is x squared plus 3. And guess what? We're done. So for the most part, that's the only thing that's on this worksheet is grouping problems and quadratic polynomials where a does not equal 1. I showed you one of each, so the rest of these should be okay. The one that you'll probably get some trouble on is this one right here. And why not? Let's go through a little bit of it just to make sure that we are on the same page. If we go through this one right here, let's just group some things together. Let's group this together, and let's group these together. So that means I have a to the 2n plus 1 plus b to the 2n plus 1 plus a to the 2n, b to the 2n plus a, b, right? So from here, I can do a little bit, I would say. This can go so many different ways, but we can just go, actually, you know what? We are going to have to go a different way on this, because the two terms that I grouped together don't have anything in common. So let's rearrange this real quick, and let's see if we can get something better out of this. Let's rearrange to have a to the 2n plus 1 plus a to the 2n, b to the 2n on one side, and then from here do plus b to the 2n plus 1. Uh-oh, hold on. To 2n plus 1 plus a, b. Alright, I think that works a little bit better. So now from this one right here, we can factor out a to the 2n. If we factor out a to the 2n, look at what's left. All we factored out was a to the 2n. So what's left here is a to the first. And then over here, which is just a. And then over here, b to the 2n, right? So that's one thing we factored out over here. And then on this side, we factor out, looking at it, all we can factor out is a b, I think. So if we factored out that b, We factored out b. What's left is b to the 2n plus a. Now, let's do the commutative property tells us that a to the 2n times a plus b to the 2n is the same exact thing as b to, well, is the same exact thing over here. I just flip those around, and that's going to be a plus b to the 2n. Wait, let's bring this over a little bit so we can see, just like that. So notice those two things are the same, right? So since that and that, they have those in common. Well, let me highlight them. This and here are the same things. We can take those out. If we take those out, we have a, you can actually, you know what, you guys can do it from there. I don't need to do any more. What you probably got a little mixed up on was that here you have a to the 2n plus 1, and I factor out a to the 2n. Well, know that, and let's move over a little more so I have some room. Know that if in fact you multiplied a to the 2n times a to the first, aren't you just adding these exponents together? So that's how I can factor out that from 2n plus 1 and just get a to the first. The same thing here, I factored out a b, and all I'm left with is b to the 2n. It's just the other way around. So because if in fact I did b to the 2n times just b, which is b to the first, aren't you just adding these exponents together? So that's how I got that. But from here, you guys should be able to do the rest of that. All right, I'm really going this time.